Hello everyone, this is our second lecture of our data science series. In the previous lecture, we have covered about basics of Python because we are going to use Python language along in this series. So if you haven't checked it out, check it the latest our previous video and welcome to this lecture. So in this lecture, we are going to cover about data preparation. What is data preparation? Data preparation is cleaning and prepping our data for further analysis. For example, we are preparing for a viva, for a test or an interview where the interviewer is testing our preparation or analyzing that how much do we know. So let's get started. In this lecture, we are going to cover these topics which are adding an index field, changing misleading values, re-expressing categorical values, and standardizing numeric fields. So, what is an index field? What idea do we get when we hear the word index? The idea which I get is in our notebook, in our lab assignments, when we write the experiment number and then the name along with their page number. So that experiment number is index field. We are giving a unique identity to each experiment, and whenever the examiner wants to fetch a particular experiment, he will just search in the index field, get the index number, and then search on the certain page number associated with that index number. This is a very easy example to understand what index field does in data science, because we are going to work with a huge data set and accessing the data from it is a major part. So if we will associate a unique identity with the elements, the accessing will become more faster. So this is the reason why we use index fields. Now let us have a look how we can add index field in our data. So let's open our console. Yes. So here when we add our index field, we'll first import the package known as pandas as PD, because writing pandas every time is hectic. So we will rename is PD because pandas is the package which will help us to work with CSV files. So now in data a block, we'll store pd.data frame. Data frame here it is provided that we are storing the values inside the name Alice, Bob, and Charlie, and their ages as 25, 30, and 22. These will be formed as in a table-like structure, like in a structured way, so that we can work upon it. And now when we because this data is not having an index, it is having name and age. So whenever we want to find it, because names can be same, like there can be two Alice and the ages can be same, but the index cannot be same, so we are adding an index field. So here when we give data an index is the field which we are adding to this data field, and then range, we are giving the range like from where to where, from where to where we want our index field. So starting from the one for obvious, then according to the data's length, this data set's length plus 1, because we use 0 like indexing. So 0 plus 1 like adding that. So length plus 1, and then we'll print. So now let us have a look on our output. Let's run this code and we'll get the index fields. Like you will get to know we have print data. We have executed the print command, data index. Here if any, we are using here the comment, and then we are storing it in the data, and here also comment. So here we get it. This is what we get. From L to Alice we are assigning 0, to Bob we are assigning 1, and to Charlie we are assigning 2, because as I said we are starting the index from 0, it is started, so that's why we are adding plus 1 here. Now let's move on to another one, this handling misleading field values. Like what are misleading field values? Misleading field values can be age in negative number, Can age be a negative number? No, it can't. So these are misleading field values. These are provided when we don't know the specific, the exact value of that column. So what are the steps we have to involve in this? Identifying errors. We have to identify the errors, like where misleading fields are actually there, where we want to correct it. Then we will clean it. For example, we'll use the replace function. So let's have a look on that function. This changing misleading field values. Here we can see that unknown is assigned because unknown can't be a name, right? And age minus one. Nah, not possible. So here in this name field, we are going to write these three names where we are going to replace. We are using dot replace function to convert or to replace unknown to anonymous because we don't know it who that person is, and then we'll replace the age from -1 to 0 because that makes sense. Obviously 0 can't be, but makes more sense than -1. We'll use 0 to represent the age we are not known. So now we will replace it, and we'll store that data in our data set. So here we can see that age is 25, 30 and 0, -1 to 0 and unknown to anonymous. Then we'll cover the next topic, which is re-expressing categorical field values, because categorical field values can be a category where it can be a gender, where male, female, or it can be the status of relationship, can be married, divorced, single, like separated and single. We have separated referred to it as, and single also represented by s, so it can create confusion. So we should write it more in a elaborated forms, so we will express it. Now how we'll express is, this is the code of expressing re-expressing our categorical field values. So here in this example we are seeing that genders are written in f, m, m, that it can be creating confusion. So rather than this, we can write it like f to female and m to male. We are mapping these values instead of changing it for each and every value, because it will be more consuming, time consuming and efforts too. So here we have changed it using the map function. So ls, instead of f it is female, instead of m it is male, and instead of m it is again male. In the later part, we are going to cover how to standardize numeric field values. Like why standardize? Why we don't need to standardize the values? What's the need? It is needed because we want to ignore the biases. We want to prevent the biases which can be there in numeric fields, because we want each and every value to contribute. So first we'll use the z-score standardization matrix or the formula, where the mean is divided by the standard deviation. So the formula is x is equals to x minus x bar by standard deviation, where x bar is the mean. So we can know what impact it creates, like what impact each variable has in our data set, because we don't want to bias one variable to have an impact all over our data set. This is how we are going to do this, like standardizing the numeric fields. From sklearn.preprocessing, we are going to import standard scalar, because this is the function which will help us to use those functions which are mean and standard deviation. So here we have fetched the data, and then scalar equals to standard scalar, because we have imported it, will help us. And then we'll use that scalar dot fit transform. Fit will be used to fetch the mean of these data sets and transform for the standard deviation. and then we will get the standard deviation and mean of this data. So this is the standardized score for each and every data. 50, for 50 it is minus 1.224745, and these are from these data. So here from this we can know that how much one field is contributing. Then we'll know what is outliers. What are outliers actually? Like what outliers are, these are the points that deviate significantly from the rest of the data. Like these are outlying, not in the group. Like you can see this one bubble outside the cluster. How we can detect it? We can detect it using box plots, scatter plots, statistical methods, z-score, and then after detection, it is very important to handle these outliers. So how we can handle these outliers? It is by depending on context. We can remove them, transform them, or we can investigate them in the future. Let's see in Python how we are going to do this. So here we are going to do this in this way. We are using IQR to identify them. What is IQR? It is interquartile range, and here again we have fetched our data in the data. Then Q1, Q3 are the variables which we have took to store the quintile range of these data sets. And then in IQR we have found Q3 minus Q1, the lower bound and upper bound. So what are these lower bounds and upper bounds? If a data set is less than lower bound or it is higher than lower bound, if its IQR value is less than lower bound or higher than lower bound, then these are outliers. So this is the statement where we did the same thing just I said, and if it is true, then this we can find. We can now here see that there is no value true for the outliers. So there are no outliers in this. Now we can see that we have handled a missing data by using the mean method or the mode method, and then we can use various techniques, which can be one hot encoding, label encoding, ordinal encoding, and it is very important to handle the missing values because these missing values can have much impact on the data and the analysis in the future. So this is it for this lecture. We'll meet again in another lecture where we will cover about exploratory data analysis. Till then, stay tuned.